This week's textbook reading was the first half of a chapter called Insulation and Temperature. This week, among other things, we will cover several important topics, including the following. First, of course, some definitions. Then we'll discuss the 7 forms of energy. We'll discuss solar energy and the 4 things that can happen to solar energy. Next, we'll discuss the greenhouse effect. And lastly, the 3 methods of heat transfer. Notably, several of these topics are really important, topics that we're going to use throughout the semester. So it's important that you master this week's material. Next week, we will build on our knowledge as we study how and why temperature varies around the world. Ultimately, next week, you'll be able to list the 5 major controls of temperature, give examples of how they work, and use them to deduce the hottest places on Earth, the coldest places on Earth, and those with the warmest average temperatures. Further, you will learn to read and interpret and even predict temperature profiles of locations around the world. Why do we care? Well, temperature plays a huge role on what the physical landscape looks like. It affects moisture levels, the presence of rain or snow, the ability of rocks to weather and erode, etc. Also, temperature helps determine the biological landscape, including what plants and animals are able to live in a region, how populations evolve through natural selection, and how these organisms affect their physical surroundings. Before we get to all that, though, we need to build our foundation, and this starts with defining some important terms. First, energy. Energy is the ability or capacity to do work. We can go further and next define work. Work can be defined as a force acting over a distance. But for now, let's simply consider that work is moving another object. That force moving an object a distance. For example, a fast-moving truck or train will do work on a parked car if they collide. The force of the truck will move the car a great distance. So in this manner, as your book points out, energy is the ability to move stuff. Notably, there are several physical forms of energy. Actually, to be more precise, there are 7 physical forms of energy. First, kinetic energy, which is the energy of motion. Potential energy, which is the energy of position. So objects high above the ground have a lot of potential energy. Radiant energy, the energy in the form of electromagnetic waves. Thermal energy, which is energy that flows from hotter objects to cooler objects. Electrical energy, which is the energy of moving electrons. Chemical energy, which is the energy stored in chemical bonds. And nuclear energy, the energy within the atomic nuclei. So any sort of energy that we'll encounter can be categorized as one of these different forms of energy. Consider a light bulb. It's giving off radiant energy. And if you happen to still use really inefficient incandescent bulbs, they give off a lot of thermal energy as well. The sun also gives off radiant and thermal energy. The food that we eat is in the form of chemical energy, and our bodies break those chemical bonds. Our car, or you traveling on a bike, have a lot of kinetic energy, energy of motion. And if you put something high up on a shelf, it may have potential energy, or perhaps the water behind a dam can be considered to have a lot of potential energy. The next 9 slides are highly annotated, and they discuss each of the 7 forms of energy. I've decided not to talk you through the information, but instead I'm asking you to read it and study it as the video rolls. I'll only be spending about 10 seconds per slide, so actually you'll likely want to pause the video several times over the next 9 or so slides. Your goal in these next few slides is be able to master these 7 forms of energy. You should be able to list them, define them, give examples, also give examples of energy transforming from one form to another. And finally, you should also be able to list the 2 laws of energy, or the 2 laws of thermodynamics that are covered in this slide set. All right, so here we go. On this first slide, you'll need to master kinetic energy and potential energy. Pay special attention to the equations so you can see how these types of energy could be calculated. Together, kinetic energy and potential energy are often called mechanical energy, and objects can transform from having kinetic to potential energy quite rapidly. Radiant energy is a form of energy most of us are a little bit familiar with. Notice that we classify radiant energy based on the wavelength of the energy. In this class, we're going to be most interested in ultraviolet light, visible light, and infrared. Thermal energy, or heat, is energy that flows from warmer to cooler objects. Did you gather that thermal energy is pretty diffuse and often not very useful? Next, electrical energy, which we use every day, is simply the energy of moving electrons. Chemical energy is the energy stored in chemical bonds. This form of energy is very important to us. Our food is a form of chemical energy, as are fossil fuels. Read through these paragraphs carefully. Lastly, nuclear energy is the energy within an atomic nuclei. Again, those are the 7 forms of energy. You should be able to list them, define them, and give examples. When we discuss energy, we'll be using an assortment of different units to talk about energy. For food energy, we're used to using the term calories. For heat energy for our homes, we often use British thermal units, BTU. For electricity, we tend to use kilowatt hours. There's many different units that we can use to measure energy with, and I've listed a few here. All right, energy transformations. We've already mentioned that energy can change form. Take a few minutes to read through some of these examples of energy transformations. I encourage you to pause the video and make sure you understand each of these examples and that you can also come up with your own examples. Next, let's consider a food chain. energy flows through the food chain. Of course, the ultimate energy source for the food chain is the radiant energy from the sun. Plants, producers, are able to transform that radiant energy into chemical energy, glucose, within their bodies. And then different animals along the food chain consume the plant and then each other to gain that chemical energy. Notice, though, that at every step along the way, some of that useful energy is dissipated as heat. Thus, food chains need a continual energy source to keep them going. And also, food chains generally aren't very long because they simply run out of energy. The two laws of thermodynamics that we'll discuss here can help us understand these energy transformations. The formal way of stating these laws is on the next slide, but basically the laws state that energy is neither created or destroyed, but it can change form. That's the first law. The second law states that when you do have energy changing form, some useful energy is dissipated or lost to that system as heat. Take a few minutes to read through our statements of the two laws of energy, or the two laws of thermodynamics. Thus far, we've identified heat as one of the forms of energy. And it flows from higher temperatures to lower temperatures. If a hotter object was touching a cooler object, or if a hotter object was placed in a cooler room, heat would flow from the hotter object to the cooler object until they were in equilibrium. Temperature can be thought of as the way that we measure heat. You can see by the definition here that temperature is the average kinetic energy of the atoms of an object. Thus, the higher the temperature of an object, the more kinetic energy the atoms of that object have. We don't see the movement, but at the atomic level, the atoms are jiggling about. Consider a solid substance, like perhaps the mineral quartz, which is really common in rocks. As the temperature of that mineral increases, the atoms move faster and faster. Eventually, if the temperature increases enough, the atoms actually have enough kinetic energy of their motion to break their bonds with other adjacent atoms, and the solid loses its rigid structure and starts to turn into a liquid. This diagram here shows an object of high temperature, fast-moving atoms, and an object with low temperature, with slower-moving atoms. You likely know that thermometers are used to measure temperature. Further, there are 3 temperature scales: Fahrenheit, Celsius, and Kelvin. In this class, we'll be using Fahrenheit and Celsius. Notably, most of the non-scientific world uses Celsius, and most scientists use either Celsius or Kelvin. Fahrenheit is only used in the United States and a few very small countries. For example, Belize, the Cayman Islands, the Bahamas, and Palau. I encourage you to begin to get more familiar with the Celsius scale. What is room temperature in Celsius? At what temperature does water freeze in Celsius? At what temperature does water boil in Celsius? How about a comfortable sunny summer day? What would be too hot a day for you in Celsius? All right, so this first video clip has covered these first 2 important points, the definitions and the 7 forms of energy. Our next video clip will address solar energy and the 4 things that can happen to solar energy.